Space, the final frontier. It beckons us with the promise of discovery and the allure of the unknown. But venturing beyond Earth presents incredible challenges. One of the greatest is the need for shelter, for habitats that can protect us from the harsh realities of the cosmos. Building in space is not like building on Earth. We can't simply load up a spaceship with all the materials we need. Transporting resources from Earth is incredibly expensive. We need a better way. The answer, it turns out, lies all around us, in the very fabric of space itself. Moon dust, space debris, these seemingly useless materials hold the key to constructing a future among the stars. Imagine a future where we mine the moon for resources, where we transform space junk into valuable building materials. This is not science fiction. This is the future of space exploration. The moon, our closest celestial neighbor, holds a treasure trove of resources. Its surface is covered in a fine, powdery substance called regolith, the product of billions of years of meteorite impacts. Lunar regolith may seem like just dust, but it's packed with potential. It contains silicon, aluminum, iron, and titanium, all vital ingredients for construction. Scientists and engineers are developing innovative methods to transform this lunar dust into usable building materials. One promising technique involves using concentrated sunlight. By focusing solar energy, we can heat regolith to extremely high temperatures, melting it into a solid, glass-like material. This lunar glass can then be 3D printed into bricks, tiles, and other building components. Another method explores the use of microwaves to sinter regolith. Microwaves can heat the material evenly, fusing the particles together without the need for extremely high temperatures. This process is more energy efficient and could potentially be powered by solar panels on the moon. As we venture further into space, we leave behind a trail of debris, defunct satellites, spent rocket stages, and fragments from collisions. This space junk poses a serious threat to active spacecraft and future missions. But what if we could turn this cosmic trash into treasure? Recycling in space is not just a good idea, it's a necessity. Instead of treating space debris as a hazard, we can view it as a valuable resource. Metal components from defunct satellites can be salvaged and repurposed. Solar panels can be refurbished and reused to power future space stations. Innovative companies are developing technologies to capture and process space debris in orbit. These technologies range from robotic arms to giant nets, all designed to wrangle in these pieces of space history and give them a new lease on life. Imagine a future where we mine asteroids for valuable metals, where we transform space debris into orbiting factories and habitats. This is the promise of a circular economy in space, a future where resources are used, reused, and recycled, minimizing waste and maximizing our presence in the cosmos. As we venture further into space, we leave behind a trail of debris, defunct satellites, spent rocket stages, and fragments from collisions. This space junk poses a serious threat to active spacecraft and future missions. But what if we could turn this cosmic trash into treasure? Recycling in space is not just a good idea, it's a necessity. Instead of treating space debris as a hazard, we can view it as a valuable resource. Metal components from defunct satellites can be salvaged and repurposed. Solar panels can be refurbished and reused to power future space stations. Innovative companies are developing technologies to capture and process space debris in orbit. These technologies range from robotic arms to giant nets, all designed to wrangle in these pieces of space history and give them a new lease on life. Imagine a future where we mine asteroids for valuable metals, where we transform space debris into orbiting factories and habitats. This is the promise of a circular economy in space, a future where resources are used, reused, and recycled, minimizing waste and maximizing our presence in the cosmos. As we venture further into space, we leave behind a trail of debris, defunct satellites, spent rocket stages, and fragments from collisions. This space junk poses a serious threat to active spacecraft and future missions. But what if we could turn this cosmic trash into treasure? Recycling in space is not just a good idea, it's a necessity. Instead of treating space debris as a hazard, we can view it as a valuable resource. Metal components from defunct satellites can be salvaged and repurposed. Solar panels can be refurbished and reused to power future space stations. Innovative companies are developing technologies to capture and process space debris in orbit. These technologies range from robotic arms to giant nets, all designed to wrangle in these pieces of space history and give them a new lease on life. Imagine a future where we mine asteroids for valuable metals, where we transform space debris into orbiting factories and habitats. This is the promise of a circular economy in space, a future where resources are used, reused, and recycled, minimizing waste and maximizing our presence in the cosmos. Imagine a future city on the moon. Instead of cold, sterile metal structures, picture buildings made of warm, earthy lunar bricks. These structures, 3D printed from Lunar Regolith, would blend seamlessly with the lunar landscape, creating a sense of harmony between human habitation and the extraterrestrial environment. Lunar Regolith offers excellent insulation against the extreme temperatures and radiation of the moon. Buildings made from this material would provide a safe haven for astronauts, protecting them from the harsh realities of the lunar environment. But it's not just about building structures. Lunar Regolith can be used to create landing pads, roads, and even radiation shielding. By utilizing the resources readily available on the moon, we can significantly reduce the cost and complexity of lunar missions, paving the way for a permanent human presence. The use of Lunar Regolith extends beyond construction. Scientists are exploring its potential in agriculture, using it as a substrate for growing plants in lunar greenhouses. Section 5. Shielding ourselves, protecting habitats from cosmic rays. Space is not a welcoming place for life. Cosmic radiation is a major threat to human health. On Earth, we're protected by our atmosphere and magnetic field. In space, we need to create our own shields. Lunar Regolith might be perfect for the job. It's rich in heavy elements, effective at blocking radiation. Using regolith in lunar habitats can protect astronauts. This is crucial for long-duration missions and settlements. Section 6. Space Waste, Earth Solutions, Closing the Loop. The challenges of space exploration often mirror those we face on Earth, but on a grander, more complex scale. Space debris, for example, presents a unique environmental challenge. But just as we strive to find sustainable solutions for Earth, so too can we apply our ingenuity to address the issue of space junk. One innovative approach involves using lasers to deorbit small pieces of space debris. By targeting debris with powerful lasers from Earth, we can slow them down, causing them to fall back into the atmosphere and burn up harmlessly. Another promising technology involves robotic arms and nets to capture larger pieces of debris. These robotic systems could then deorbit the debris or transport it to a central location for processing and recycling. By developing and implementing these technologies, we can not only mitigate the risks posed by space debris, but also create a more sustainable space environment for future generations. Building in space is a monumental undertaking. It's not just about designing and constructing structures that can withstand the harsh conditions of space, but also about overcoming the logistical challenges of transporting materials and equipment. One of the biggest challenges is the sheer cost of launching anything into space. Every kilogram sent into orbit adds to the overall mission cost. This is why utilizing resources found in space, like lunar regolith and space debris, is crucial for the feasibility of large-scale space construction. Another challenge is the extreme environment of space. Temperatures can fluctuate wildly between extreme heat and bitter cold. There's no atmosphere to speak of, and micrometeoroids pose a constant threat. Working in space also presents unique challenges for astronauts. They have to perform complex tasks in bulky spacesuits with limited mobility and communication delays. Robotics and automation will play an increasingly important role in off-world construction, minimizing the risks to human life and increasing efficiency. The quest for sustainable space exploration is driving a wave of innovation, leading to the development of groundbreaking technologies that could revolutionize not just how we explore space, but also how we live on Earth. 3D printing, for example, is playing a crucial role in our plans for space colonization. This technology allows us to create complex structures and tools using only the materials at hand, reducing our reliance on Earth-based resources. Imagine 3D printing entire habitats on the Moon or Mars using only local materials. Another area of rapid advancement is in situ resource utilization, or ISRU. ISRU focuses on using resources found at the destination, such as water ice on the Moon or Mars, to generate fuel, oxygen, and other essentials. These technologies, along with advancements in robotics, artificial intelligence, and closed-loop life support systems are paving the way for a future where humans can not only visit other worlds, but also establish a sustainable presence beyond Earth. The idea of humans living on other planets, once relegated to the realm of science fiction, is now within the realm of possibility. The technologies we're developing to build with moon soil and space debris are not just about overcoming the challenges of space exploration, they're about building a future among the stars. Imagine self-sustaining colonies on the Moon and Mars, where humans live, work, and thrive. These colonies would not just be outposts of Earth, but new branches of human civilization, pushing the boundaries of knowledge, innovation, and human potential. Space colonization is not just about escaping Earth's problems. It's about ensuring the survival of our species and expanding our reach into the cosmos. It's about answering fundamental questions about our place in the universe and searching for life beyond Earth. The challenges are immense, but so are the rewards. The spirit of exploration that burns within us, the same spirit that led us to walk on the moon, is now leading us to build a future among the stars. As we venture beyond Earth, we carry with us a profound responsibility to ensure the sustainability of our actions and to preserve the pristine environments we explore. Space, in its vastness, may seem limitless, but its resources are finite, and its delicate balance can be easily disrupted. We must learn from the mistakes we've made on Earth and strive to be responsible stewards of the cosmos. This means minimizing our impact on other celestial bodies, managing space debris responsibly, and utilizing resources sustainably. Imagine a future where space exploration is not just about scientific discovery, but also about environmental stewardship. A future where we work together as a global community to ensure that our presence in space is a positive force, leaving behind a legacy of knowledge and inspiration for generations to come. The future of space exploration is in our hands. It's up to us to rise to the challenge, to embrace innovation, and to ensure that our journey among the stars is a sustainable one, for ourselves and for all of humanity.
So hit that subscribe button, ring the bell for notifications, and let's turn the page on a new adventure together. Get ready to experience books like never before, only on VBook 360. Like, comment, and share to support the channel and keep the video magic alive. Thank you for stopping by. And remember, every video has a story, and every story deserves to be shared. See you in the next video.